Okay, section 3.4 is all about optimization, and we're going to start by looking at a curve. And normally we go from minus infinity to plus infinity on this curve, and you would have relative maximum here and a relative minimum here. But we want to talk about absolute maximums and minimums. So we're going to look at this not from minus infinity to plus infinity, but on a closed interval. So when we stop this thing at particular points, it has endpoints. And now the curve that we're looking at is only from this one point to the other point. And now you see we've got this point and this point. We have a maximum here and a minimum here. The question is, where are your absolutes? So we're going to be looking for absolute maximum and absolute minimum. And you see this is a relative max right here, but this goes up higher. This is a relative minimum because in this little area that's the lowest point, but this is an absolute maximum because now we don't have an infinitely long curve. We only have this short curve on a closed interval. So what we're going to do is we're going to take a function. We're going to find all of the critical values of that function, and then we're going to find the y values at the critical points and at the end points. And what we have to do to figure out where our absolute maximum and minimum points are is we have to just plug it in and find the y value. Remember, maximum and minimum all depends on how high or low the point is. So let's check this curve. It's just a parabola, and we're going to check it on this closed interval here. So we take the derivative, set the derivative equal to 0, factor it, set the factors equal to 0. I get a critical value of x equals 1. What I need to do now is find the y value at each of these endpoints and at my critical point. So where do you find your y values? You plug them into the original function. This is so much easier than graphing, guys. So I'm going to plug the 0 in, and I get minus 3. Plug the 2 in, and I'm going to get 4, minus 4, and the minus 3 gives me minus 3. Both of those values are the same, but that's okay. Plugging in the 1, I end up with a negative 4. That's a mistake. Hello. Holding the phone here. Negative 4. So now we see that my absolute maximum occurs at the highest y value, and the biggest y value here is negative 3. So my absolute max y value equals negative 3. And my absolute minimum is the lowest y value, and that equals negative 4. It's pretty simple, right? Now, if you change the interval that you're on, it's going to change your absolute maximums and minimums. Let's look at another problem and work it on different intervals. Okay, let's look at the same problem that we used before in the last video. This is a cubic. We know what a cubic looks like because we've graphed plenty of them in pre-calculus and in this class. Let's start on the interval minus 2 to plus 2 and see what happens. So the first thing you do is find your critical numbers. We should get 2 critical numbers from this. So you take your derivative, set it equal to 0, factor, and solve for x. And we're going to get that x equals 5 and x equals negative 1. Now, look at the interval that we're looking at. We're going from -2 to +2. So we have to find the y values at each of these endpoints. And then we have to find the y values of the critical points, but only the ones that are in the interval. So -1 is between -2 and +2, but 5 is not in this interval. Okay, so plugging in these x values, and you always plug it into the original equation. So I'm going to plug in the -2. This is -8/3, -8, +10, +3. Calculate that out. 13 minus 8 is 15. -8/3 gives me 7/3. Sorry, 15/3 minus 8/3. All right, plugging in the +2, same numbers, different signs. I get a different answer. This is -15 plus 8/3. Significantly different answer. Plugging in the -1. Be careful with your signs. All right. Six minus 1/3. 18/3 minus 1/3 is 17/3. There we go. Now your highest value will be your absolute max, and your lowest value will be your absolute min. And remember, we didn't bother with the 5 because it wasn't on the closed interval that we were looking at. All right, let's try the same problem on a different interval. Same f of x, but on the interval 0 to 10. So we need our y values. We know our critical numbers, those didn't change. Notice that -1 is not on that interval. So we're going to check our endpoints and the 5. So plug in a 0. -1's not between 0 and 10, so we're not going to bother with that one. Plug in the 0, easy enough, we get a 3. Remember, we're plugging it into the original equation. Plugging in the 10, we're going to get ew, nasty number. -200 minus 50 plus 3. And I got to get a common denominator. So 1,000 minus 250 times 3. And then plus 9/3 gives me 259/3. All right, plugging in the 5. 5 cubed over 3. Yeah, 125/3. Minus twice 25, minus 25, plus 3. Just plugging and chugging now. So minus 72 plus 125/3 gives us this. Obviously, this is the highest value. So this is our absolute max, and this is our absolute min, our lowest value. All right, one more time. Same problem on a different interval. Let's try it on -2 to 6. So we're going to check our endpoints. We already did the -2 up here. Plugging in the 6, we've got 6 cubed divided by 3, which is 2 times 2 times 6 squared, minus 2 times 6 squared, minus 30 plus 3, and we get negative 27. And now both of these critical values are found between our endpoints. So we have to plug in the minus 1, which we did right here, and we have to plug in the 5, which we did right here, minus 91 over 3. The absolute minimum, by the way, 91 divided by 3 is 30-something. So this is the lowest value that we found. That's our absolute minimum. And this is the highest value that we found. That's our absolute maximum. All right? It's pretty straightforward stuff, guys. Take your derivatives, find your criticals, plug in the endpoints and the criticals that are on that interval. The biggest one is the max. The smallest answer is your min. That's all there is to it. Enjoy your homework.